Yeah, let's go there. Okay. Now we should be okay. My goodness. I've been sitting here talking. I've got at least one person up here, and it's not me. Usually it's me up here. Um, again, a little impromptu tonight, but let me bring up Twitch and I will double check to make sure that the mic's working. It had it set up for some iTunes mess. It was not my Blue Snowball like it should be. Ein Moment. Give me just a second to bring. And in this case, I'm just bringing up my iPhone or my Razer phone and looking at I see you guys. Yeah, you can't hear me because I had the wrong mic checked. So ha ha ha. Hey, if you guys are on in a little bit, I'm only going to be on here for a few minutes doing a review. If you guys want to play some Dead by Daylight or something, I'd be game to play a couple. But I appreciate you guys stopping by. There we go. Okay, Flash can hear me. I'm going to do a quick check, make sure I can hear myself. Now I hear nothing. Flash and Hasty together again. Man, if we were only gaming instead of doing stats. Looks like it's locked up on here, but this is the Twitch side of things. So let me go to Stream Manager. My goodness. Here. Yeah, I hear my voice. So at least hear that. So it sounds like it's going okay. I'm going to tilt this over here just so I can watch it for a little while. If it locks up a bunch, I apologize. Again, I have not streamed in a little bit. I only had one from this semester earlier with the online office hours. Yep. Stats that bind us. Okay. I'm going to close that out because I think I'm okay now. I think, let me do one last check. Let me make sure that I've got, yep, there we go. Okay. So all I'm doing is a few problems tonight just to set us up. I'll try to do a few more of these tomorrow, so you'll have a couple of them. I want to talk about addition rule tonight, and I want to talk about two problems in particular, and they are right here in front of you. Hopefully you can see this okay. If you're looking on your phone, I don't know if it's easier or not to see on your phone. On my iMac, I see it pretty well. So we're going to select a card. So a typical classroom example, right? So we're doing an addition rule where we have some event going on, another event going on. We can have either one of these events. If they are mutually exclusive events, we don't subtract out their overlap at the end. If they are not mutually exclusive, then we have to subtract out that middle piece of it. In other words, let's see if I can get this on this little piece here. And let's talk about this one right here. Let's talk about selecting a card. So a card is selected at random from a standard deck, 52 card deck. Find each probability. So we'll go here, randomly selecting a club or a 3. Well, if this is selecting clubs, then this would be selecting a 3 because there is a club that is a 3, so there's overlap in the Venn diagram. Now, if you were selecting randomly selecting, say, a club or a heart, you'd be looking at maybe something like this, club and heart. Oops. So the probability of selecting a club or a heart, those are mutually exclusive events because they cannot occur at the same time. You cannot choose one card and have it be a club and a heart in a standard deck of cards. So that's not what we're dealing with here, though. We are dealing with this as it pertains to this classroom type problem. So we are randomly selecting a club or a 3. The way that looks like in our setup is as follows. And you do not have to write this, for those of you from my class, you do not have to write the formulas like I had you do previously on the exam 1. So, but we're working with the addition rule here. This is an OR situation. That's your buzzword. So we've got the probability of selecting a club or a 3. And that's going to be equal to the probability of selecting a club plus, because this is the addition rule, the probability of selecting a 3. Subtract that overlap in the middle from the Venn diagram, and you're going to have the probability of a club and a 3. So you're going to subtract out that. Okay, how does it look? Let me switch colors just to put the numbers underneath, and they're still showing. The probability of drawing a club in a 52-card deck is 13 out of 52. There are 13 clubs in a deck of cards. We're going to add that to the probability of choosing a 3, and there are how many 3s in a standard deck of cards? There's 4 of them, 4 out of 52, and then subtract the overlap. How many 3s in the deck are also clubs, or how many clubs in the deck are also 3s? There's just 1 out of 52. So when you go 13, 17, so you've got 16 out of 52. Double check my math. 13, 14, 56, 17 minus 1 is 16. So then I want to check my calculator real quick. Showing up much better in the lighting here. So you're looking at about a 31% chance. So about a 0.31. That's your probability of randomly selecting one card from a standard deck of cards and having it be a club or a 3. So there's one type example that you might see on your exam. And remember, I assigned these out to you, And I've taken questions up to this point, and so far there weren't many questions. Folks were honest and said some of you had not worked through many of them. But remember, it's important to work on these problems that I assign in between class to make sure that you understand exactly the types of problems that I'm given both in class, on quizzes, and on tests. Okay. I would ask for questions, but I don't think anybody from class is here, but maybe they are. I know Hasty and Flash stopped by. I appreciate them stopping by, probably on the Twitch. They're on the Twitch side of the house. I see that right there. And again, if you boys are up a little bit later, maybe play some Dead by Daylight or something. We'll stream that too. I don't know. I'm sure there's a million people out there that want to watch me play Dead by Daylight following a stats review. All right. So that was the first one we did. We did this one. Now let's do the very next one here, randomly selecting a red suit or a king. So it's the same idea. So is there a king that is a red suit? Yes, there is. So there's overlap here. It's still going to be the addition rule. So you're going to have the probability of selecting a red suit. I'm just going to put red or a king. Addition rule. So it's the probability of choosing a red plus the probability of choosing a king. Subtract out the overlap. The probability of selecting a red and a king. Now, how many kings are red in a deck of cards? This probability is a little bit different than the last one. Same type of problems, or same type of problem as before, however, a different probability. So probability of red. Now, this is different as well because for red, you've got diamonds and hearts. So you've now got 26 divided by 52. That's your probability of choosing a red card. So 50%. You got a 50% chance of getting a red card if you randomly select it from the deck. To select a king, there's still only 4 kings in the deck. So we've got 4 out of 52. And then at the end here, the overlap. How many kings are also red, or how many red cards are also kings? And there are 2 of them. So same idea as the previous problem, but different probability. So just different computational sets at the end. So 26 plus 4, that's 30 minus 2. You got 28 over 52. So it's slightly over 50%. Back to my calculator check because I like the way it looks now. I tell you, streaming is not an easy thing just to jump on here. You got to get everything set up. I have some virtual calculators that I like to bring up, but all of a sudden my Restream won't bring it in. It won't recognize it as a program. I have to do the whole screen if I do it, and that just defeats the purpose, in my opinion, in case anybody was wondering. So 28 divided by 52. Oh, yeah. And what I say, just slightly over, so about 0.54 if we round to 2 decimal places. So a card is selected at random from a standard deck. Find each probability. We worked through the probability of selecting a club or a 3. We just worked through the probability of selecting a red suit or a king. Now I want to work through randomly selecting a 9 or a face card. Again, same idea, different types of problems. So let me erase this mess out of the bottom down here. And for those of you, I know some folks may sign on and see this going on and think, what in the world is this mess? This is just online office hours that I do for my statistics night class because I don't have office hours for that class. So I do it virtually. It's always optional. This particular one is impromptu because I needed to get a review out there. I was working on a video to post out there in Camtasia, and I could not get it where it looked halfway decent where I could post it. I told the students the other night in class that I had them, which I do. I do these videos. It's very easy to do the video, but I could not get it to not look fuzzy. I just could not get it worked out. So, all right, let's look at this last one. Let's look at this last one right here. Randomly selecting a 9 or a face card. Okay. Now I got to think about this for a second. There are 4 9s in the deck, a 9 of hearts, 9 of diamonds, 9 of spades, 9 of clubs. So there are 4 9s. And there are how many face cards? Well, face cards are considered to be Jack, Queen, and King. Those 3 right there. So there are your face cards. If I select one card, do I have any shot of selecting a card that is both a 9 and a face card? And the answer is no. So it goes back to my Venn diagram from earlier. the two events are mutually exclusive. They cannot occur at the same time for this simple level problem from a classroom set. So here's the probability of selecting a 9. Here's the probability of selecting a face card, right? They do not overlap. There are no 9s that are face cards and no face cards that are 9s. But we do the problem the same way. It's just that what you're subtracting off at the end ends up being 0. It's just like an empty null set. There's nothing there because there's no overlap. So I go to the probability, what am I looking at? Probability of choosing a 9 or a face card. And I'll just put FC for face card. So I get the probability of choosing a 9 plus the probability of choosing a face card, subtract out 0 because there's nothing there. We don't even have to write that out there. I'm just doing it for illustrative purposes. So I'll just take this out. Boom. And now I'll go down here. I'll do it in red. So the probability of choosing a 9 is 4 out of 52. There are 4 9s in a deck, and we have those 52 cards sitting there. The probability of choosing a face card, there are 4 of each of these. So it's 4, 8, 12. So I've got 12 out of 52. So I've got 16 out of 52, which, if I'm not mistaken, is about 31%. I did it earlier. There it is right there at the top of the calculator. 0.307, which is 0.31. Sorry that it had to adjust a little bit. So there it is. And we're here. So the probability of randomly selecting a 9 or a face card is the same as the probability of randomly selecting a club or a 3. Now, I'm sure there's some patterns that we could dive into in a separate algebraic type class, but for the purposes of this, these are separate problems. I'm just trying to walk through some examples that you might see, like the ones you might see on your exam, and certainly the ones we've seen in class. Okay. The last thing I will talk about right here is just the form that I've been going over. Make sure that you know these forms. So I hand out note sheets. I upload them to the Moodle. Make sure that you're studying them to some extent, and you know them. Of course, I let you bring a 3x5 note card in, fill it up front and back with whatever you need. My philosophy on that is that over the years, it doesn't matter. You either know it or you don't. And once you fill out that note card, you typically commit it to memory and don't even need the note card. That just gives you a little security blanket. So the probability of choosing A or B is the probability of A. This is the form that we were working from, plus the probability of B. Subtract out the probability of A and B. Now, I've been using this for and, just because I was running out of room. But that's it. There's the form from the addition rule. I love the addition rule. I just think it flows very well computationally. All right. I've been writing right on the page. Let's look at the very next one. Actually, let's look at the one up. Give me a second and let me push out a dossier. Earlier, I was talking about at the start of over there. At the start of my stream, and I do this because I'm curious when other people are streaming, I always talk about my stream setup, which is nothing fancy. It's what I have pieced together over the years. And I talked about it earlier, but nobody could hear me because I had the wrong mic selected. The program defaulted to another one. I didn't catch it. So I got a 2015 Mac. It's at the end of its life, but it runs like a champ still. I use Restream or I use Ecamm that works with Macs to stream from. Ecamm is a shell kind of like OBS, but it's easier to work with than OBS in my opinion. And I have cameras set up, and I have a document camera over there on my calculator, Blue Snowball mic, nothing fancy. I have an older iPad and a newer iPad that I use to stream with, and that's it. There's really nothing fantastic. I know when I watch some people stream their games, it is fantastic. I see all their stuff, but they also make money at this. I make zero. I do this just for the sake of students, and I just enjoy doing it. So let's take a look at another problem. This might be the last one I do, just working with addition rule. Then I'll come back tomorrow, work with multiplication rule, permutations, and a few other ideas that we talked about in class for this probability exam that we've got tomorrow. So let me look at number 16, can defects. I don't think we did this one in class. I think we did a different defect problem. So A company that makes soda pop cans finds that the probability of producing a can without a puncture is 0.96. The probability that a can does not have a smashed edge is 0.93. And the probability that a can does not have a puncture and does not have a smashed edge is 0.0893. So when we're looking at A right here, I haven't looked at this in a while. Let me see. Let me make sure I read this right. Are the events selecting a can without a puncture and selecting a can without a smashed edge mutually exclusive? Explain. Okay. Excuse me. So in other words, if I reach into wherever the cans are and I pull out one can I get a can that does not have a puncture, and does not have a smashed edge? And the answer is yes. I can pull one out that doesn't have a puncture and does not have a smashed edge. In fact, we were given a probability right up there. So those two things can occur at the same time. These are kind of some double negatives within the writing of this problem. I like the problem, but you have to kind of weed through that. So are the events selecting a can without a puncture and selecting a can without a smashed edge mutually exclusive? They are not mutually exclusive because they can occur at the same time. And that's my explanation, because they can occur at the same time. If a quality inspector randomly selects a can, find the probability that the can does not have a puncture or does not have a smashed edge. So this is event A, does not have a puncture. This is event B. So that's A, and that's B, does not have a smashed edge. Now, back to the original form. So the probability of A or B equals the probability of A plus the probability of B. Bear with me. Subtract out the overlap in a Venn diagram of those occurring at the same time, which they can. They are not mutually exclusive. So we have a probability out there at the end because those events A and B can occur at the same time. So our probability of A does not have a puncture. Well, we're given, as far as the numbers go, we're given A. One second. Selecting a can without a puncture is 0.96. So I got 0.96 plus, kind of a funky looking plus. Try again. There we go. The probability of event B, which does not have a smashed edge, is 0.93. And subtract out the overlap, which is actually given. I don't have to determine what it is. I don't know that I could without some empirical data. It's right there, 0.893. And what does that equal? Well, let's go to my handy dandy calculator that I'm very proud that I have back up and running. There it is. Clear. Once it focuses, did it focus? Kinda. Let me try it again. Let's autofocus and lock it. That's better. Let me try it and lock it. That's not better. That's better. I'm sorry that I'm messing around with this. That's the thing about this stupid camera. There we go. Okay. So I'm looking at 0.96 plus 0.93 equals, subtract out 0.893, I think it was. 0.96, 0.93, 0.893, 0.997. Excuse me. So the probability that a quality inspector randomly selects a can, the probability that the can does not have a puncture or does not have a smashed edge is 0.997. So there's a very good chance that you get a can with no defects whatsoever. Poof. That's it. Ta-da. That's the end of it. I think my music has disappeared, by the way, which drives me batty. I don't know. Maybe we're still going. I'll find out or not. Okay, so there are 2 or 3 examples there from the addition rule that I've done tonight for a video that's up here for you. This is for my class. These are the types of problems that you might see on your assessment. Same ones as the ones assigned. I may even assign them back to my book where I've actually circled them. So I hope this helps a little bit. Anybody else that came on, I always appreciate folks that come on here, especially if you interact a little bit. AC and Flash came on and said hello. We play Xbox together some here and there. And so it's good to see them stopping by and saying hello. I always appreciate that. And anybody else, I saw that we had 5, 6, maybe 7 folks up here at one time. Maybe it was just curious folks stopping by to see what the heck this was, and then they quickly got out. Or maybe it was some of my students. I don't know. Anyway, that's all I've got for you right now. So I'm going to sign off from this, and I will catch everybody back tomorrow. I'll try to do a couple, maybe one early tomorrow, then one tomorrow afternoon. And that'll give you at least 3 review side pieces so you'll have an understanding of what will be on the exam. Maybe I'll even show an exam up here, one of my older ones. I don't know. We'll see. All right. That's all I've got.